sigma C value is given 120 megapascal, and question is asking to determine the size of the rivet how much. So here number of rivets given 7 total, 1, 2, 3, 4, 5, 6, 7. Total 7 rivets is given in a 7. So all are same as the question is given. All are same size, that is asking in question how much d value. So for this, in design procedure, the first point is we need to calculate the center of gravity for the given system. So the center of gravity I am calculating now, x bar x1 plus x2 plus x3 plus dash 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 x7 by n number of rivets. In same manner, y bar y1 plus y2 plus y3 plus dash dash plus y7 by n number of rivets. So x1 how much? Suppose this is the x-axis and this is y-axis. This is y-axis. Now x1 how much? The x is nothing but horizontal distance from the y. So there is no distance for the first rivet. For that reason, x1 is 0. x2 how much? Distance from the axis, vertical axis to this distance. How much this is? The question is given in 100. Now how much x3? x3 that is the third rivet. The third rivet from this vertical axis to the distance is 100 plus 100, total 200. And x4 how much? This is a fourth rivet. Now from the vertical axis to this distance, total 200. Now x5, this is a fifth rivet. x5 how much? From the vertical axis to this distance, total 200. And x6 how much? There is no distance, 0. x7 Sam, are you there? ఇప్పుడు వచ్చింది సార్. Is it appearing above my screen? Yes, hello. Hello.
Yes, sir, appearing.
So we were here. What is y2? Y2 is the vertical distance from the horizontal axis. How much distance total? 200. In the same manner, y3 also 200. Y4 100. Y5 0. Y6 0. Y7 100. Okay. Substitute the all values here. Now tell me the x bar how much and y bar how much. Make it fast. Tell me the x bar how much, y bar how much. Substitute the x values in this equation, y values in this equation. Get the x bar and y bar. Make it fast, Babu. How much, Babu? Nobody is interested.
Sir, X bar is equals to 100.
Y bar? Y bar how much? Y bar how much, Babu?
114.28.
Very good. 114.28. I'm writing P. Okay, the first step is over. Now the second step is introducing the two forces. One is P1, one is P2. So center of gravity I'm locating here. So x bar is 100. It means along this vertical line, the x-axis is going to located, and y bar is 114.3 means up to here 100 plus 10 somewhere here. This is center of gravity for this system. Okay. Now introducing the two forces. One is the P2 from the top side. P1. P1 is responsible for the direct shear because the self weight of this column, whatever the horizontal added here, due to the adding the self weight acting vertically downwards. That is direct shear, PS, 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 PS. How much direct shear due to the direct loading? So that is second step here. How much this one? Total load by n number of rivets. Direct shear on each rivet. That is total load by n number of rivet. That is 50 into 10 to the power of 3 by 7 rivets. Now direct shear load on each rivet how much? 7143 newtons. And due to the this is responsible for the first load, and the second one secondary shear forces. The secondary shear forces are generated due to the application of this eccentric loading at a certain distance 400 mm. Now due to this the secondary shear forces are going to generated in a clockwise direction because the eccentric load is added in the clockwise direction. The secondary shear load is in this manner. Okay, separately I'm drawing here. This is the center of gravity. I'm joining the rivet, this rivet to center of gravity, this rivet to center of gravity. First rivet, second, third, 7. Now, due to direct loading, the shear load is distributed vertically downward on each rivet that we calculated. Now, secondary shear force is generating on each rivet that is perpendicular to the line joining from the rivet center to the system center. That is in this manner, perpendicular to this line. Before so how much this one? These forces are generated in secondary shear forces on each rivet that I am calculating now from this equation. P into E equal F1 by L1 into L1 square plus L2 square plus L3 square plus dash dash L7 square. Okay. Now how much L1? L1 means this length is L1. This length is L2, L3, L4, L5, L6, L7. Now how much each distance? So to calculate L value, I'm showing the relation. So suppose if I draw one line, it will form a one right angle triangle. That one I'm showing separately here. This is the first rivet. Okay. This is the 100 mm given in the question. This is the L1 that we need to calculate. Now this is the CG for the system, and this is the second rivet. Now how much here to here distance? How much here to here distance? Suppose from here to here 200, it means it is 100, it is 100, total 200. Now the center of gravity for the system, just now we calculated this one 114.3. Now what is this distance? How much? The distance is, if we subtract the 200 minus 114.3, 200 minus 114.3, how much, Babu? 200 minus 114.3. How much, Babu? 200 minus 114.3. $85.7. Now, as per Pythagoras theory, tell me the L1 value. 100 square minus 100 square plus 85.7 square. Now, how much L1? Make it fast. How much, Babu? L1? How much L1?
131.69.
131.697 I'm writing. Okay, so that is L1 we calculated. Now how much L2? L2 is the this distance from this rivet center to this center. From this distance represents the L2. Just now we calculated 85.7 mm. Now L3. L3 how much? Same, because it is a symmetrical about y-axis. So how much here to here distance? Same distance we can find, that is L3. Okay. Now we need L4 value. To calculate L4 value, if you want to draw the one horizontal line and if we join this one, so it will form one right angle triangle that I'm drawing separately here. This is L4 and this distance is given in the question 100, and this distance we don't know. So to know this distance, the total center of gravity from bottom to here 114.3. Now here to here 100 mm. So subtract 114.3, 114.3 minus 100. That will give 14.3 is the length of this set. Okay. Now as per Pythagoras theory, what is L4? 100 square plus 14.3 square. 101.01. Very good. Okay. Now what is here? Because the fourth rivet and seventh rivet position same, but in a symmetric manner. So the reason L4 we can consider L7. Okay, because if we draw the one line here and join this one, same right angle triangle is forming here. L4 is common. L1 and L3 is common. Please mute yourself. Now what is L5? To get the L5 value, if I draw this one, it will form a one right angle triangle that separately I'm drawing here. This is the fifth rivet, and from here to here 100 mm that is given in the question. This is the center of gravity for the system. Now what is the length of this one? The length of this one is total from here to here center of gravity 114.3. 114.3. Now what is L5? So calculate it as per Pythagoras theory. 100 square plus 114.3 square. So if you calculate L5, L6 and L5 have the same length because the position of the rivet is same. The fifth rivet is placed right hand and sixth rivet is placed at left hand. So same length we can find. So how much L5?
1.86.
One. Sorry. Please repeat again.
151.86.
151.86 means I am writing 152 mm. So it is also known as L6. So totally L1 to L7 we calculated. Substitute the all values here in this equation. P value is given in the question 15 to 10 to the power of 3 into 400. E value is given in question. F1 we don't know. L1 just now we calculated how much? 131.7. 131.7 into 131.7 square plus L2 85.7 square plus and L3. So L3 again 131.7 square, L4 value L4 101 square, L5 152 square, L6 L6 where is L6? L6 also same as a L5, that is 152 square. L7 is 101 square. Now substitute the value in calci and get the F1 value in terms of newtons. Get the value of F1. How much F1 Babu? Make it fast. How much F1? Rule number 1. Are you there? Venkata Sai Teja.
Yes, sir.
Now what is F value? Rule number 3. Ati Babu. Are you there?
Yes, sir.
Tell me the F1 value, Babu. Why you are taking too much time? Rule number 13. 13 rule number. Zain Babu is not there. Rule number 28. With rule number 28. Akila. She is also not there. Rule number 35. 41. 46.
Yes, sir.
There, sir.
Tell me the F1 value. We don't have time. I am depending on you, Babu. Whatever the answers you are giving, I am writing on screen. Sherry Babu, are you there?
Yes, sir.
No. Tell me the F1 value. Harshita? Are you there, Harshita? She is not there. How much F1? Get it fast.
Sir, 24244.26.
244 24 244 again.
Yes, sir. 24244.6. 26.
Very good. Okay. F1 value we calculated. Now we need to calculate F2, F3, F4, F5, F6, F7. See the diagram. F2, F3, F4, F5, F6, F7. So these values are we can calculate by using the following relations. F2 means F1 into F2 means F1 into L2 by L1. F3 the relation is hello. अस्सलाम वालेकुम सर मैं क्लास में हूँ सर अभी फ़ोन करता हूँ सर मैं F3 means F1 into L3 by L1. F4 means F1 into L4 by L1. F5 means F1 into L5 by L1. F6 means F1 into L6 by L1. F7 means F1 into L7 by L1. Now get the values of F2, F3, F4, F5, F6, F7. Make it fast. This relation how we got, I already explained in the previous class. Okay. Don't worry how we are getting this relation. How the equations are generated, I already explained in the previous class. Now tell me the F2, F3 in terms of newtons. F1 value already just we calculated. How much F1 value? 24244. F1 is 24244. L1, L2, L3 are values we calculated in previous. 24244 into L2 how much we got? 85.7 by L1 how much we got? 131.17. Now tell me the F2 value in terms of Newton. 24244 131.17. Now L3 how much we got? L3 also same in terms of newtons. 24244. L4 how much we got? 101. 24244. L5 how much? 152. How much was that one? 158.39. F2 okay. $158.39. F3 24341. F4 18667. F5 28093. Two eight zero nine three. Very good. One eight double six seven. Okay, Babu. So on each rivet, see the diagram. On each rivet, two forces are generating. One is a direct shear force, one is a secondary shear force. Here also, one is direct shear force, another is secondary shear force. Here also same. It means on each rivet, two forces are generating. So that is the reason there is a resultant stress for the first rivet, the resultant stress for the second rivet, there is a resultant stress for the third rivet. In same manner for the fourth rivet. So here it is. Here the resultant stress. Here this is a resultant stress, and here there is a resultant stress. So how much resultant shear stress? That is so according to parallelogram theorem, the resultant shear stress equation is resultant shear stress for the first rivet Ps square plus F1 square plus 2Ps F1 cos theta 1. So theta 1 cos theta means theta 1 how much? Suppose if you draw the separate triangle, so already it is drawn. This is the first rivet and this is the theta 1. Okay. So cos theta means 100 by L1. Cos theta means 100 by L1. L1 how much we got? 131.17. How much, Babu? Make it cos theta 1. Calculate cos theta 1. Tell me cos theta 1 value. 100 by 131. How much, Babu? 0.76. Very good. Cos theta 1 100 by L1. L1 value we calculated 131.17. That is 0.76. Substitute here. Now R1 value how much? No, not degrees, just cos theta 100 by L1 how much? This value we have to substitute here. Now direct load we calculated previously. How much? 17143. 7143 square plus F1 how much we got? 24244. 24244 square plus 2 into 7143 into 24244 into 0.76. So get it R1. R1 how much? 333. Very good. 333 newtons. Now R2. To get the R2, the equation is PS square plus F2 square plus 2PS F2 cos theta 2. So in the figure, we can't find that theta 2 value. So that's the reason cos 0 I'm writing. Now the equation is PS is 7143 square plus F2 how much we got? F2 we got 15839. 15839 square plus 2 into 7143 15839 into cos 0. How much was cos 0? Tell me the R2 value. Double two 982. Very good. Double two 982 newtons. In same manner, R3. R3 is PS square plus F3 square plus 2PS F3 cos theta 3. So theta 3 how much? Theta 3 equal to theta 1 only. Because two rivets are positioned in same manner. Okay. So how much we got? 7143 square plus 24244 square plus 2 into 7143 into 24244 0.76. It means same value we can find as a R1 333
Sir,
newtons.
sir, but F3 value is not 24244, no, sir.
Wait. Yeah, sorry. 24341. 341. 24341. Now tell me the R3 value. R3 value how much? Three zero one 30129 newtons. Now R4 how much? R4 R4 is PS square plus F4 square plus 2PS F4 cos theta 4. Theta 4 how much? So separate triangle we need to construct. Already it is constructed here. This is theta 4. So theta 4 is cos theta 4, that is 100 by L4. How much bro? 100 by L4 how much we got? L4 value 101. 100 by 101. How much bro? 100 by 101? How much bro? 100 by 101. 0.99. Okay. Seven one four three square plus 24 F4 how much? R4 how much? 18667. 18667 square plus how much, Babu? 25758. 25758. Very good. Now same manner, tell me the R5 value, R6 value, R7. So I think R R4 and R7 is same, 25758 newtons. R6 and R6 R5 both are same. Tell me the R5 value, then we'll get the automatically. Get it, R5 value. In terms of newtons. Make it fast, Bob. R5 is PS square plus F5 square plus 2PS F5 cos theta phi. Cos theta phi how much? Theta 5. This is the theta 5. So cos theta phi. Theta cos theta means 114.3 by L5. 114.3 by L5. L5 how much we got? L5 value. Where is L5? This is the L5. 152. 114.3 by 152.75. That is cos theta phi. This is 0.75. Now tell me cos R5 value. Double 3, 235. 35, 235. So R6 also same. Now let's see the figure. So here the load is applied, eccentric load. So due to this load, initially the maximum the force is generated on the first rivet. The first column rivets are going to subject to maximum load. Then after distributing the load, this load on the first column rivet, then and second column, then on third column. It means actually no need to calculate this all values here. Only the first column, whatever the directly facing to the load is enough. So it means the maximum, there is a chance of maximum load generated on the rivets, the first column of rivets. Just see here, F1 how much we got? F1 value, sorry, R1 value how much we got? R1 value 3033 and R2 value 2000. Again, R3 value is R3 3129, and R4 value, where is R4? Here it is. R5, this is the one. R6, R7. So among the all values, which one is the maximum value? 7 R values we calculated. Here is R1, this is R2, R3. This is the R3, R4, R5, R6, R7. Among the R values, which one is the maximum? Which one is the maximum? Just see. R5 and R6, very good. R5 and R6 is the maximum value. So for the safe design, R5 value, otherwise R6 value, we are taking into consideration. How much? 35 to 35 newtons. It means, for your understanding purpose, I calculated all R values, but no need to calculate because in general, the first column of rivets are going to subjected to maximum resultant force. Okay, no need to calculate these are all things. It is time consuming process. Just if you calculate the first beginning, whatever the load here applying, this load is going to face first initially on the first column of rivets. So that's the reason, just if you calculate the first column, that is enough, and that is decided the maximum value. Okay, so this is the resultant shear stress, R5, R6. So how much resultant shear force? So the shear force actual equation is pi by 4 into d square into sigma s. That is 35 to 35 equal pi by 4 into d square d that we need to calculate. Sigma s value is given in the question. How much, Babu? Sigma s value 65 megapascal is given in the question. Now get the value d in terms of mm. How much d? Make it fast, Babu. How much d value? Everything is written on the screen.
Sir, next class time is going.
Yes. It is ending the class. 26.27 means 26.27 means 26.3. The diameter of the rivet hole. So this is the diameter of the rivet hole. So based on this rivet hole, we are selecting the diameter of the rivet. So how much the diameter of the rivet? The table I already showed in the previous class. So based on the table, we are selecting the diameter of the rivet. So for this 26.3, diameter of this is the whole diameter. Now we are selecting the diameter of the rivet as 24 mm. So according based on table, we have to check for the respective value. For the diameter of rivet hole 26 mm, how much diameter is indicated in the table? From that table, diameter of the rivet is 24 mm. Okay. Now, whether it is safe condition or not, we need to check. For that, crushing stress value is given 120 megapascal. We have to check this one. For this, crushing stress is crushing load, that is 15 to, sorry, maximum load 35 into 235 by D into T. D value 26.5 and thickness of the plate is given in question 25 mm. Now tell me the sigma C value. Make it fast. Sir is waiting. Next class. Sigma C value how much? How much, Babu? Make it fast. 53 megapascal. Okay. So 53 means the question is given 120 megapascal. Our induced crushing stress is 53. It means our induced stress value is less than the permissible value. So that's the reason our calculated design is safe. Hence, design of rivet for eccentric loading is safe. Like this, you need to write the comment. Okay, we'll do another problem on this topic because it's an important topic. Is there any doubts you can ask? Otherwise, we will end the meeting. Shall I end the meeting?
Yes, sir.